Okay. So we pick junction 2 and start with it. So at junction 2, the members that connect, we have the one from 2 to 1, one from 2 to 5, and one from 2 to 3. Please, do you see that?
Yeah.
Yes. So they are moments. So moments from 2 to 1 plus the moment from 2 to 5 plus moment from 2 towards 3
Yeah.
should sum up to 0 because we are at a joint. Then you do same for junction 3. So at junction 3, what do you think is going to happen? The moment from 3 to 2 plus the moment from 3 to 4 plus the moment from 3 to 6. Should all sum up to 0. Very good. So we are done setting up our equations. The next thing that we do is to determine these moments, the M21 and the M25 and the rest. So we come M21. If you remember, third year, we did something like we found moments. Like if you want to find the moment, you have to find the capital M faced. Do you remember something like that?
Yeah.
M faced, then you find plus some 2 theta.
Is there the one under structural analysis?
Yes, 2 theta over, I think, L into brackets. Do you remember something like that?
Yeah.
Some theta things, theta A, I think
Yeah, I
minus
remember.
plus. You remember something like that?
Yeah.
Very good. So this M fixed comes in when you have like a load on the member. Like if there were to be some uniform loadings somewhere, you get it? That will be acting in between the members. That's when the M phase comes in. But when you have no load on the member, like if you pick this member 1 to 2 like this, you actually don't have any load on the member. Do you get it? Yes. The
Yeah.
loads are acting at joints, like at joint 2, you have a load there, joint 3, like that. It's not really acting on the individual members. Do you get what I mean?
Yeah.
Yes. So this one, it's like it's going through this, and this one too is going through this. So we take this one out and we deal with this part. So let's move on with that. Okay. So when you have M21, now M21, let me clean it. Now the M21, that's from this side to this side. Because we have and there are these conditions that you should take note of. The first condition, let me first give you like the whole thing so that we'll be moving fast. The whole concept about this. You could see there is this load P passing through 2,5. Do you see it? And there is a load P passing through 3,6.
Yeah.
Yes. these are all going to result in like some modifications to the formula that I put up here.
Okay.
So what you should expect is that when you have, like I'm giving you the conditions so that as we start, you'll be flowing like you know whatever you are doing. So these are the conditions. When you have when you have no load passing through when you have no load passing through the member, like member
Yeah.
1, 2, do you get it? When you have no
Yeah.
load passing through member 1, 2, or like member 1, 2, we have no load passing through it. But when you take member 2, 5, you have a load passing through it. When you have no load passing through the member and the member is having a fixed support at the far end. When you pick this member, like at this junction, the 2 is the near end, and this one is the far end.
Okay.
When you have something like the far end is phased, what is going to happen is that you are going to use 4 EI 4 EI over L theta 2 plus 2 EI. And this formula is coming from the M phased and then the 2 theta, whatever I wrote on the board when we started.
Okay.
Yes. So this, the near end, you apply a factor of 4 to it. And the far end, you apply a factor of 2. And you bring their thetas. So you could see 4, your EI over L should be constant. Then your theta 2, that's the near end, plus 2, a factor of 2 for the far end. So 2 EI theta 1 over L. Please, have you seen it? So this is when no load is passing through it. No load. No load is passing through and one end is phased. So this is the near end and this is the far end. Please, do you get it?
Yeah.
Yes. And the same thing applies to like no load passing through when you have like something like this here and here. Do you get it? Like when you have, I don't know how to describe the joint. Here, this place, it's like a pin. No, should I? No, it's like a, what do you call it? It's like a hinge or a fixed support. So you apply the same thing over there too. Do you get it?
Okay.
Yes. And let me go to condition 2. So the condition 2 is such that when there is a load passing through it, so when there is a load passing through it, the near end, what you are going to do is you apply R and the theta at the near end, EI over L plus what will happen to the far end is you apply RC. Then the far end's theta, EI over L. Please, do you get it?
Okay.
Yes. So, and the third one is when you have a pin support at the extreme ends.
Okay.
So when you have a pin support, that one, what we use is the modified, I don't know whether you've heard it, a modified stiffness. Have you heard the modified stiffness?
Hello.
Hello, can you hear me?
I'm saying that the second one, under what condition will you use that one?
The second one,
Yes.
when you have a load passing through, like this one that there's a
Okay.
load passing through.
Okay.
Yes. So, as I said, we are moving on to when you have a pin. So maybe imagine this side is a pin. Like what would happen to it? That's what I'm talking about. Do you get it?
Yeah.
So when you have a pin and there is no load passing through it,
Okay.
the far end becomes the pin. Do you get it? Because obviously here is the far end and within it is the near end. So what you do is that at the near end, you apply 3 EI theta at the near end over the length.
Okay.
That's it. You don't apply anything at the far end because we assume the far end, which is this one, it will go to 0.
Okay.
Yes. And when you have so have you noticed them? Have you noted them down?
Yeah.
Yeah.
So that means that for the third one, it's only 3 EI theta over
Yes.
L.
Yes, please.
Okay.
That's for the first one. The third one. Okay. And also, sometimes, you might have then the next condition, can I bring that on board?
Yeah, you can.
With this, a pin support and a load passing through it. Do you get it?
Yeah.
It is going to be, so this is when there is no load passing through, but the
Okay.
far end is pin.
Okay.
So when there is a load passing through and the far end is also pin, what will happen to it is that this time around, you are going to do R prime EI over L theta. This theta is the theta for the near end. Please do you get
Okay.
it? The far end,
Yeah.
everything will go to 0. So can we move on now?
Yeah.
Yes. So um okay, sure. So if you can move on, then I think that's basically what the conditions you should know. So I said the first one is what? Do you remember?
The first condition.
The first condition is what?
That's when no load is
It's passing
pass.
through,
Yeah.
and you have a fixed end somewhere. Do you get it?
Yeah.
Or the same thing is for when you have like middle spans or spans that these ones these the ones I'm talking about. You use this. Do you get it?
Yeah.
But then when you have what is for the second condition? Do you remember?
Okay. Maybe you can come again on that one.
So the second one, I said when
Is it
you
the one
have
when no load is passing through?
this is when no load is passing through.
Okay. The
No load.
first one.
Yes, no load.
Okay.
So this is when load is passing through it.
Okay.
Do you get it?
Yeah.
When load is passing through it for fixed and middle spans that you don't know the type of support.
Okay.
Yes, this is no load. This is when there is load. And the last one is
When no load is passing through and the far you have far end as the pin.
yes, yes. And this one is
When load is passing through.
yeah. When load is passing through and hello.
Yeah, I'm listening.
So when load is passing through and the far end is pin, right?
Yeah.
Okay, very good. So these are the conditions we are going to consider. If you have these down, I think we can move on.
Okay.
Okay. Can I clean it?
Yeah.
Let's go to the next page. Okay. So I wanted to copy this. They said I'm running out of time. Have you seen that the message?
Is that?
They were like, I'm running out of time. So let's go.
Oh,
At do you have the draw? You have the I've sent you a picture of it, right?
yeah, I have it.
Okay, so let's start at junction 2. So J2. So at junction 2, We are going to find what? M21. Is that correct? Plus
Yeah.
M what? M25 plus
M23.
M23 to be equal to 0.
Yeah.
So what is M21? Let's go on. So we do them separately, then we put them together. So M21, do you see that there is no load passing through M21? 21 member. Have you seen that?
Yeah. There's no load passing. Yeah.
Yes, and the far end is also faced.
Yes.
So my M21 is going to be said that it is equal to my 4 for the near end. You remember?
Yeah.
And I said the near end is where you are taking this one from. So the 2 is the near end. So 2 over L plus the far end. The far end is what? 2. I hope you remember this formula. I just moved
Yeah.
on.
2EI theta over L.
Yes, so theta 1, that's for the far end. The far end's theta is theta 1.
Okay.
Okay. But you can see that the far end is what? Is faced. Do you get it? And when we began, I said when you have a fixed end, you have your slope to be what? There will be no
0.
slope over there. Do you get it?
Okay.
So I first identified the joint 1, joint 4, joint 5, joint 6 to have theta to be what? 0.
Yeah.
So this is that's theta for the far ends joint. So theta 1 is 0. So this place will be cancelled out because here will go to 0. And we are left with what? M21 to be equal to is what? 4EI.
4EI theta 2 over L.
Yeah. Over L. Very good. So you put this somewhere, then we move on. Let's move. So moving on. So we put this somewhere. Then we go to M what? M25.
M25.
Yes. So M25, what is happening over there? Is there a load passing through?
Yes.
Okay, so there is a load passing through. The far end, how is it like? The far end is faced, right?
Yeah.
Okay. So if there is a load passing through and the far end is faced, we use the R and RC.
Yeah.
You have the formulas over there, right?
Yes.
Okay, so R and RC. So I have R, E, R. And you have to check your eyes because you could see that for 2.5, the I is 2I. Have you seen it? Check on
Yeah.
the drawing. So here
Yes.
you can put 2 here. So that comes, then your theta 2 comes because that's the near end all over L.
Okay.
This plus your what? Your RC, is that correct?
Yeah.
Your RC, EI, mind you, the I is 2I. So EI, you can multiply it by 2. This is in a bracket, don't be confused. All over what?
Okay.
L. Then your theta 2, your theta 5 comes. But you know, your theta 5, is it 0 or it's something that we can determine?
Yeah. So that's the end, the
far end.
end.
Yeah,
far
the
end,
fixed.
yeah.
So the fixed end, you can see it's 0, right?
Yeah.
So theta 5 is 0. And this is going to make the whole of this side 2 goes to 0. So what are we having for? So we now have M25 to be equal to what? R
REI.
2 R EI theta 2 all over what? The length. And you could see the length is L, right? Sometimes it could be 2L. You have to take notice of it.
Oh, okay.
Yes. So this is what we are having right now. And you can call it, you can put something around it. Okay. So can we find the M23?
Yeah.
Okay. So M23, now that you can determine, I hope you can do M23.
Yeah.
So what are the conditions? M23, you have, it's like the middle ones.
Yeah.
So the middle ones, I said, when there are no load passing through them, we choose like four for near end and 2 for far end, remember?
Can you come again?
The middle ones, I said you treat it like the ones with the far end and then this one.
Okay.
You use the 4, you remember the 4 theta 2?
Yeah, yeah.
So here the theta is not, is what, this is the near end, so theta 2 EI over L
Okay.
plus what, 2 theta what, 3 EI over L, is that correct?
Yeah.
So this is M23. Okay, but is the theta 3 negative? No. The theta 3 is not negative, unlike the fixed ends that they are negatives. Do you get? Wait, the theta 3 is not 0, sorry. That's what I wanted to
Yeah,
say.
because it doesn't have any, is it because you don't have a fixed end?
Yes, it's not a fixed end. Do you get it? Yeah. So we leave it like that. Please take note. Don't put 0 here.
Okay.
Yeah. So we are done with the components. It's left with us to put them together. Do you get it?
Yeah.
So putting them together, I think our time is almost up. So I'll meet you in the next video and you'll put them together and try and
Okay.
find them.